this lecture, I'll present Model-Driven Engineering, or MDI. This software creation approach is not adopted widely, but it is important to know. The main idea of model-driven engineering is to create a system without writing a code. In an ideal world, after creating a model, we just click the play button and the whole system is generated. We don't even look at the program code. Proponents of the MDA argue that this raises the level of abstraction in software engineering, so that engineers no longer have to be concerned with programming language details or the specifics of execution platforms. Model-driven engineering is still at an early stage of development, and it is still unclear whether or not it will have a significant effect on software engineering practice. In the ideal case, so many advantages could be seen. For example, software bugs would be eliminated, we could transfer the program to many different platforms, and so on. The problem is that we need very detailed models, and usually it requires too much effort to make those models. It takes too much time and requires very qualified specialists. Model-driven architecture, or MDI, is shown in the slide. Models at different levels of abstractions are created. From a high-level platform-independent models, it is possible in practice to generate a working program without manual intervention. The picture on the right shows the context of model-driven approaches. At the lowest level, we have a model-driven architecture that is concerned about creating an architecture using models. Then goes MDD, that is a model-driven development. It shows how to create a system using previously described architecture. Model-driven engineering is the whole software engineering that is based on modeling. And finally, MBI is model-based engineering. 3 types of models shall be created in model-driven architecture. A computation-independent model, where important domain abstractions are used. A platform-independent model for operations modeling without reference to its implementation. And platform-specific models that are transformations of the platform-independent model with a separate PSM for each application platform. But what does modeling look like in this case? At first, we create a computation-independent model by showing the functionality of business systems, and these model domain abstractions are used in that system. Then we create a platform-independent model. The PAM is usually described by UML models that show the static system structure and how it responds to external and internal events. The final step is to generate platform-specific models. These are transformations of the platform-independent models with a separate PSM for each application platform. In principle, there may be layers of PSM, and every layer adds some platform-specific details. This way, from the computation-independent model, we get executive code. Of course, it is impossible to generate something from business diagrams. An architect is needed that creates models using, for example, Magic Draw or some other tool. The specific model can be generated, but it requires additional tools, so-called translators. If we have a specific model, we can generate executive code. To make a model structure or generate a skeleton of the software, it is not a very complicated task. The most interesting and the most complex task is to describe the logic of your program. In other words, create algorithms with UML. For a long time, UML didn't have tools for programming logic implementation. Later, executable UML was created that was based on a separate action language. Several action languages were created for the platform-independent models. However, this implementation requires writing new codes, and only one action language used graphical notations. The Object Management Group has standardized the foundational UML, which was strongly influenced by executable UML. Finally, action language for foundational UML was created, and it is standard action language specification developed by the Object Management Group. The developers of MDA claim that it is intended to support an iterative approach for development and can be used within an agile method. The notion of executive upfront modeling contradicts the fundamental ideas of the Agile Manifesto. If transformations could be completely automated and a complete program generated from the PIM, then in principle, MDI could be used in an agile development process, as no separate coding would be required. However, it is too soon to talk about agile design and MDA, because the MDA is not working perfectly yet. At first, MDA looked like a very attractive tool that could reduce programming time, expenses, and improve programming codes. However, it did not spread out widely because of its complexity, time consumption, and other issues. A range of factors has limited the adoption of MDA. Also, a specialized tool support is required to convert models from one level to another. There is limited tool availability, and organizations may require tool adaptation and customization to their environment. For the long lifetime systems developed using MDI, companies reluctantly develop their own tools or rely on small companies that may go out of business. For more complex systems, implementation is not the major problem. Engineering requirements, security and dependability, integration with legacy systems, and testing are more significant. The widespread adoption of agile methods, or the some period that MDA was evolving, has diverted attention away from model-driven approaches. The main focus right now is on pragmatic MDA. It means that we don't try to create the software from models alone. We pick the best MDA ideas that work and use them in different workflows. This way, the programs could be created faster. In this picture, you see the blueprints of the Unreal Engine. It is actually a visual code modeling language, one that creates again without writing a single line of code. The key points of this lecture. Model-driven engineering is an approach of software development where models rather than programs are the principal outputs of the development process. The idea is to generate software from models. In order to generate software, CIM, PIM, and PSM models should be created or generated. Foundational UML along with ALF action language allows describing the logic of software. The widespread adoption of agile methods has diverted attention away from model-driven approaches. That's all for today. Thank you for your attention.